It feels like every other week there's just this huge leap in AI, doesn't it?
Oh, absolutely. It's moving incredibly fast.
It's amazing to watch, but honestly, keeping up, it feels like trying to drink from a fire hose sometimes. Are we really grasping the shifts without just getting completely swamped?
That's the challenge, isn't it? And that's really why we do this.
Exactly. This is the deep dive. We're here to be that shortcut, to cut through all the noise and help you understand what actually matters in these massive changes.
You want to distill those key insights, help you wrap your head around the real implications so you can navigate all this.
And today,
Yeah.
wow, today we're diving into something really fascinating out of Google.
Yeah, something that feels like it's shifting the whole relationship. It's moving beyond AI just helping us
Right.
towards what the source we're looking at calls a true partnership.
And that source, our guide for today, is this really compelling article, Google Jules the New Colleague in the Cloud.
hmm
And it really hits hard on this idea we need to unpack, agentic AI.
Agentic AI. Yeah, that term itself signals a pretty big leap.
So that's our mission today, right? Let's unpack what Jules really means.
Let's do it. We'll break down the tech concepts behind it,
Yeah.
try to make them clear and accessible for you listening.
And really explore what this could mean for the future of work, especially, in software development where things change so fast anyway.
Definitely.
Hmm.
So let's maybe start with how we even got to this point.
Okay, yeah. To really get what Jules represents, we kind of need to rewind a bit, look at the foundations. And the story of AI that we really started seeing, the one that grabbed everyone's attention, it arguably kicked off, big time, on a game show.
Right. IBM Watson, Jeopardy, 2011.
Exactly. It wasn't just playing, it was beating Ken Jennings and Brad Rutter, the best of the best.
Yeah.
That wasn't just TV entertainment, it felt like a landmark. It introduced this era of the expert system.
And it's worth really understanding what that meant back then, an expert system.
Yeah, break that down.
Well, these systems were basically built on really specific pre-programmed knowledge. Think of incredibly detailed flowcharts.
Okay.
Like, the source gives this example. If a patient has symptoms X, Y, and Z, then the system suggests tests A, B, C.
So very rule-based, hand-fed information.
Exactly. Hand-fed, rule-based, super powerful within its narrow lane, like the very structured rules of Jeopardy.
But that was the catch, wasn't it? And amazing on the Goose Show.
Mm-hmm.
But then it hit the messy real world. And that initial awe kind of faded when people tried to apply it more broadly. Why was it so brittle?
Well, precisely because it was so specialized. That power in the closed system of Jeopardy didn't translate well.
Right.
These expert systems just couldn't generalize. They couldn't adapt to ambiguity or the nuances of human language or problems they hadn't been explicitly programmed for.
So if the question was phrased slightly differently or the situation didn't perfectly match its rules?
It fell apart. It couldn't really learn or handle novelty. It was brilliant in its box, but the real world isn't a neat box. It hit a wall.
And then 2017 happened. That seems to be the real turning point everyone points back to.
Yeah, a pivotal year.
This paper from Google Brain researchers. Just one paper sounds almost humble. Attention is all you need.
Deceptively simple title, right?
Yep.
But that paper, and crucially, Google's decision to open source the work, that was the earthquake.
Okay.
It introduced the transformer architecture, and this just completely changed the game for how AI could process language.
Before that, it was more sequential, like reading one word at a time.
Pretty much, yeah. Things like recurrent neural networks, RNNs, they struggled with long sentences, with understanding how words at the beginning related to words way at the end. Context was hard.
So, transformers.
Mhm.
What was the I know it's technical, but what did it unlock for, understanding language?
Well, the core idea, the attention mechanism, let the model weigh the importance of all words in a sentence simultaneously, no matter where they were.
Ah, okay, so it could see the whole picture at once.
Exactly. It could understand context, grasp the relationships between words far apart, much like our brains do instinctively. It could finally understand the flow and meaning of complex text. That was the aha
Now
point.
that just blew the doors open.
Completely. The old expert systems, suddenly obsolete. This sparked what the source calls a Cambrian explosion of large language models, LLMs.
Right, leading eventually to things like ChatGPT that everyone started using.
Suddenly you had AI that could write essays, summarize articles, hold conversations with, well, stunning fluency.
And this seems crucial, that first wave, amazing as it was still fundamentally like super sophisticated autocomplete, right?
That's a great way to put it. Incredibly powerful autocomplete, yes. Fantastic tools for assisting humans.
But assisting being the key word, you were still the pilot.
Absolutely. You prompted it, you guided it, you checked its work. It can generate code snippets, answer questions, brainstorm ideas.
Yeah.
But the human was driving. It was an extension of your intent.
Okay. So that was the era of the assistant. But the source we're looking at today says that era. It's evolving into something much deeper. We're moving into a new paradigm.
Yeah, pretty fundamental shift.
Let's talk about the metaphors we use. Copilot has been huge in software development AI, right? GitHub, Copilot, etc.
Everywhere.
But what does Copilot really mean? Like, in an airplane, it's the junior officer executing the pilot's commands. Capable, yes, but limited autonomy.
Right. The pilot in charge makes the decisions. The co-pilot helps execute them efficiently and safely, but follows orders.
Then you have autopilot. A step further, maybe?
A bit, yeah. Autopilot can follow a preset flight plan. You tell it the heading, altitude, speed, and it can manage that. Reduces workload significantly in routine flight.
Good. It's still just following a script.
Exactly. The source uses a great analogy. If unexpected bad weather pops up, the autopilot will fly right into it unless the human pilot intervenes. It doesn't understand the goal of the flight, just the programmed path.
Okay. So Copilot executes detailed instructions. Autopilot follows a pre-programmed plan. Mm-hmm.
And the source says Google Jules just shatters those comfortable paradigms.
Yeah, this is where it gets really interesting. Jules isn't a co-pilot or an autopilot. The source calls it a co-captain.
Co-captain. Okay, what's the difference? That sounds like a fundamental change in relationship.
It is. A co-captain doesn't just follow orders or a script. They share authority and responsibility. They understand the mission, the ultimate goal, not just the flight plan.
So back to the storm analogy.
The co-captain sees the storm on the radar, understands its potential impact on the mission's success, and can proactively say, hey, maybe we should reroute this way. It's safer and still gets us where we need to go. They can make course corrections.
Wow, okay. So this isn't just assistance, it's delegation with trust.
Genuine delegation.
Think about what that means psychologically for a developer. It's not just telling a junior assistant exactly what code to write.
Right.
It's like briefing an experienced partner, someone you trust to figure out the details, maybe even suggest a better approach. Precisely. And this elevates the human's role. You move from focusing on the tactical line-by-line execution
the debugging, the syntax,
up to the strategic level.
Yeah.
You're thinking about the architecture, the overall project direction, the user needs. You're setting the vision, the why, and trusting your co-captain, Jules, to handle a lot of the how.
That's a huge shift in abstraction. You're freed up from the weeds.
Exactly. Think about the mental energy saved, the focus regained. That's the promise here.
And the source really highlights one word that defines this new way of working. Asynchronous. That seems key.
Oh, absolutely transformative.
Yeah.
Think about the daily grind for a developer, or really anyone doing deep thinking work.
Constant interruptions, right?
Constant battle against friction and context switching.
Yeah.
You finally get into that defocus zone, wrestling with a complex problem.
And then ping. A meeting reminder.
Yeah.
Or a Slack message where you have to stop and run tests.
Exactly.
Yeah.
Every interruption breaks that flow, and it takes real time and mental effort to get back into it. It's exhausting.
So, Jules, as this co-captain, offers a way out of that churn.
That's the idea. It acts as a sanctuary. When you delegate a task, say, write a complete test suite for this feature, you're not just saving typing time.
Right.
You are literally buying back hours of your own uninterrupted, focused attention. Your most valuable asset.
So you can delegate that task and then, what, turn your attention elsewhere?
Completely. Dive into that complex architectural design, have a deep strategy session with product management, or honestly, just log off for the day.
Knowing that Jules is working in parallel.
Exactly. Working diligently, tirelessly. You don't have to babysit it. You don't have to wait for it synchronously.
And the source describes this experience of coming back later, maybe the next morning, and finding a completed, review-ready pull request.
It's a novel experience. For anyone unfamiliar, a pull request is how developers formally submit code changes for review and merging. Finding one done, autonomously generated, that feels different.
Less like using a tool.
And more like leading a team, where you have this capable, autonomous agent contributing significantly, even when you're not actively managing it.
That's the core promise of this agentic model, then.
It's a force multiplier. It lets human engineers reclaim that role of architect, strategist, creative thinker.
Instead of just being implementers bogged down in the day-to-day churn.
Precisely. Focusing on the truly novel, complex problems that require human ingenuity.
Okay, so this co-captain capability isn't magic. The source says it's like a buddy cop pairing of technologies.
I like that. What are the two cops here?
Yeah, so on one hand, you've got the brain. That's Google's Gemini 2.5 Pro.
Okay, the advanced LLM.
Right, but specifically tuned for reasoning, for understanding complex systems. It can look at a whole code base, multiple files, understand the connections, the logic, and then devise a sophisticated plan.
So it figures out the strategy, the what and how.
Exactly, but a brain needs hands, right?
To actually do the work.
And the hands are a secure, sandboxed Google Cloud virtual machine. Okay, sandbox. That term comes up a lot in computing. Let's break that down. Why is a sandbox so important here?
It's a massively powerful concept. A sandbox is basically an isolated, safe environment. Think of it like a digital playground.
Walled off from everything else.
Completely walled off from the real system, your live code, your data. You can run code in there, test things, even deliberately break things.
Without any risk to the actual project.
Zero risk. It's contained. Any mess stays in the sandbox.
And the source emphasizes that this isn't just crucial for AI, but for human developers too. That idea of fearless experimentation.
Oh, totally. For a human coder, it's where you try out that crazy idea, follow a weird hunch, attempt something maybe stupid just to see what happens.
Without worrying about bringing the whole system down or getting judged.
Exactly. It's crucial for innovation. You need that safe space to fail and learn quickly.
The source has this great analogy, calling the sandbox a digital equivalent of human imagination. That's pretty profound.
It really is.
Yeah.
Think about how we mull over ideas in our heads, right? We explore possibilities, some good, some bad. We follow flawed logic, have silly thoughts.
Silently, privately.
Yeah. We don't have to justify those internal trial and error processes. We only test the final refined idea. The sandbox gives the AI that same freedom. It can try approaches, debug its own attempts, iterate internally without consequence or external judgment.
So for Jules, the sandbox isn't just a feature, it's foundational. It's where the learning and reasoning actually happen.
It's absolutely essential. It's where the AI gets to do the work. It can clone the code repository, make its own safe copy, install the needed software tools, run tests, modify files, test its own changes, all safely isolated.
It's like its own private development environment.
Exactly. A consequence-free zone for it to act, observe the results, and refine its approach, just like a human would on their own machine.
So neither the Brain Gemini 2.5 Pro nor the sandbox work alone. It's the combination.
Absolutely critical. A brilliant brain with no hands is just theory. And hands, without a sophisticated brain, are just blindly following simple scripts. It's the synthesis, the high-level planner, understanding the whole strategy, paired with the grounded executor that can actually manipulate the code and test results that lets Jules tackle complex real-world software problems.
And one more detail about that sandbox, the source mentions it has internet access. Why does that matter?
Oh, that's huge. It means Jules isn't limited to the knowledge it was trained on, which might be months or years old.
Ah, so it can look things up.
Exactly. It can check the latest official documentation for a library, find current best practices, look up new APIs, even browse forums for solutions to tricky issues.
So its solutions are not just smart, they're current.
Precisely. It keeps the AI grounded in the constantly evolving reality of software development. Its hands are always working with the latest information.
Okay, let's shift gears a bit. Every software project deals with this thing called technical debt. It sounds ominous.
It can be, yeah. It's like this invisible drag on progress.
The source uses a really effective analogy to explain it, comparing it to financial debt. Can you walk us through that?
Sure. Imagine a company wants to build a new factory fast. They take out a loan, borrow money to get started right away.
Okay, makes sense.
In software, the loan is taking a shortcut. Maybe a quick hack to fix a bug, skipping writing tests to meet a deadline, ignoring a dependency update because it looks complicated.
Things you do to ship faster, basically.
Exactly.
Yeah.
And initially, it feels good. You got the feature out, met the deadline, you feel productive.
There's always interest on a loan.
Always. And in software, the interest payments are the extra time and effort everyone on the team now has to spend working around that initial shortcut forever after.
How so? Give me an example.
Well, that quick hack might make the code harder to understand, so the next feature takes longer to build. Or it introduced a subtle bug that takes days to track down later. That skip test lets a new bug slip into production, causing customer issues. That outdated dependency suddenly has a critical security flaw, forcing an emergency fix, or it conflicts with new libraries, causing build failures.
So each shortcut creates future work, future friction.
Exactly. And it compounds. Each shortcut adds to the principal debt, and the interest payments, the slowdowns, the extra debugging, the rework just keep growing.
Like a snowball effect.
Absolutely. Over time, developers end up spending more time fighting the tangled, brittle code, paying the interest, than actually building valuable new stuff. Project velocity just grinds to a halt.
And the worst case, the source says, is bankruptcy.
Yeah. If you let it get bad enough, the codebase becomes so fragile, so complex, that any change breaks multiple other things. Innovation just stops.
Because it's too risky or too expensive to change anything.
Right. The only option left is often a complete, incredibly expensive rewrite from scratch, declaring bankruptcy on the old code. It's how seemingly small, maybe even rational short-term decisions could eventually kill a project.
Wow. Okay, that's a sobering picture. So where does Jules fit in? Can it help with this technical debt nightmare?
That's one of its key proposed benefits. The source calls it an agent of engineering hygiene.
Like an automated cleaner?
Kind of, like an automated debt repayment service. Think of it as a tireless accountant combing through the code base.
Finding those shortcuts, those pockets of debt?
And systematically paying them down. It automates the development toil.
What kind of toil are we talking about?
The stuff humans often put off because it's not glamorous new feature work. Writing those tests that got skipped, refactoring messy code to make it cleaner and more maintainable, updating those old dependencies that are causing problems or security risks.
The essential maintenance, basically.
Exactly, the chores. By handing these over to an agent like Jules, teams can stop that interest from compounding. They can actually start reducing the principal debt.
So it's not just about going faster on new things.
No, it's about the long-term health and stability of the project. Ensuring its solvency, you could say.
It's like enabling craftsmanship at scale.
That's a great way to put it. Freeing up human developers to focus on innovation, on building the future, not just constantly servicing the debt of the past.
Now, this next part feels like maybe the biggest leap we've discussed, moving beyond just following instructions.
Yeah, the source talks about features that suggest Jules is developing a kind of, well, intellectual integrity.
Starting with something called the critic agent. What is that?
It's basically an internal quality control mechanism. Think of it as an automated peer reviewer that challenges the agent's own code before a human even lays eyes on it.
So it critiques itself.
Yes. It's designed to find flaws in its own proposed solutions, look for edge cases it might have missed, suggest improvements. It's a self-correction loop.
The source uses a fun analogy, a digital Jiminy Cricket.
Yeah, like a conscience on its shoulder asking, are you sure that's the best way? Did you consider this scenario? Is that efficient? It pushes the agent towards more robust, well-crafted solutions internally.
But it gets even more nuanced. The angel and devil on the shoulder analogy, how does that play out?
Well, true innovation isn't just about following rules, right? Sometimes you need to bend them or break them.
Okay.
So the angel part of the critic ensures adherence to best practices, security rules, coding standards, the lawful good way.
Doing things by the book.
Right. But the constructive devil represents chaotic creativity. It's the part that might suggest an unorthodox approach.
Something outside the standard playbook.
Exactly. It understands that maybe the old rules don't apply perfectly here, or that a riskier, unconventional path might lead to a breakthrough. It's like a potential for a beneficial mutation.
So this internal debate, this tension between following the rules and potentially breaking them creatively.
It builds trust. You know, the output hasn't just been spat out. It's been internally debated, challenged, and refined.
It's moving away from a black box AI.
Towards something more transparent, something that can reason about its own quality. It's a big step.
And complementing this critic agent is another feature, interactive planning.
Right. This really cements the shift from command and control to collaboration.
How does that work? What's different?
The agent can actually ask you, the developer, clarifying questions. If your initial request is ambiguous or maybe even contradictory.
It doesn't just guess or fail.
No, it can come back and say, okay, I understand the goal, but I need clarification on point X. Or to do this effectively, we need to decide between option Y or Z. What do you think?
That's the difference between talking to a junior assistant versus a senior colleague, right?
Exactly. A colleague might push back, ask questions, help you refine the plan before execution starts.
So the goal shifts. It's not just about the AI executing the task perfectly.
It's about collaboratively ensuring the task itself is correctly defined and the approach is optimal.
That feels like the dawn of a true reasoning partner.
That's exactly what the source suggests. Shared understanding, shared problem solving.
So Jules itself sounds pretty impressive, but the article frames it as more than just one product. It calls it a bellwether.
Yeah, a great term. A bellwether is like the sheep with the bell that leads the flock. It shows you which way things are heading.
A leading indicator.
Exactly. Jules is seen as a key piece of Google's broader strategy towards agentic AI. The ambition isn't just fixing code, it's automating complex, multi-step tasks across all kinds of knowledge work.
Project management, research, design, you name it.
So focusing only on what Jules can or can't do today kind of misses the bigger picture.
Right. It's about the trajectory.
It forces us to rethink what skills are most valuable, especially in engineering.
If an AI can write perfect boilerplate code, the basic stuff,
Then the human value moves up the stack, as they say, for higher level thinking.
the source uses this fantastic education analogy. I really liked this.
Yeah, it's very clarifying. It compares it to university degrees. A bachelor's degree trains you to provide great answers. Master existing knowledge, apply known solutions.
Okay.
But a PhD trains you to ask great questions, identify gaps, frame new problems, push boundaries.
So if AI gets really good at providing the answers,
Then the premium skill for humans becomes that PhD-level inquiry.
which means
The ability to break down complex problems, to clearly articulate intent to the AI, and, critically, to evaluate the AI's output, knowing what questions to ask and how to judge the answers.
so the most valuable engineer isn't the best coder anymore.
But the one who can formulate the most insightful question, orchestrate the AI, and critically assess the results, that's the provocative takeaway.
That's a profound shift from answer provider to question asker.
It really is.
Okay, so let's wrap this up. We started way back with Watson, the expert system on a game show, moved through the LLM era, the super autocomplete, the AI assistant,
The co-pilot at our side.
and now, with things like Google Jules, we're looking at the start of true AI partnership, the co-captain.
Yeah, the core message really feels like the new colleague has arrived.
Doesn't need a desk, though. Has a secure VM in the cloud.
Right. Works while we sleep, learns while we focus on other things. It's evolving from a tool into a partner.
So the era of the AI assistant, the co-pilot, it's giving way to the age of the autonomous AI colleague.
A force we direct and collaborate with, rather than just wield.
This feels like more than just a new tool. It's a whole new way of building things.
Absolutely. It's set to reshape the art, the science, the economics of software, and probably much more for years to come.
And it's fascinating that meta point the article makes, that the article itself was written collaboratively between the human author and Google Gemini.
Yeah, a perfect example of the very partnership we've been talking about. Eating their own dog food, so to speak.
Okay, so a final thought for you, our listener, to chew on. If the future really is about AI mastering the answers and humans mastering the questions, what unquestionable truths in your own work, your own field, might need a second look?
Yeah.
What assumptions could be reframed as a better, more insightful question now that we have these potential reasoning partners emerging?
That's a great question to leave people with. Something to really mull over. Keep digging into what this shift means for you. Thanks for joining us on this deep dive.